6 combinations. Today we will be learning about how to find the number of combinations of items. And this picture over here it's called the combination lock, but it's ironic because even though it's called the combination lock, it's actually a permutation. And today we're going to go over why it's a permutation, not a combination. Okay, so it says Robbie is at Domino's Pizza. He's ordering a 2-topping pizza. Toppings he can choose from are sausage, pepperoni, and mushrooms. Each topping can only be used once. That's why I underlined that part, because that's going to really come into play here. And we're going to create a tree diagram. So I started out by this is back to day 1, so I just have so we can have the sausage, pepperoni here, and then mushroom. So that's for our first topping. For our second topping, we can't choose sausage again because it says each topping is only used once. So once sausage is already on the pizza, I'm going to make that into a P instead. So we can't have sausage again. So instead I put down the next one, which was pepperoni. We can either have mushroom. And the same goes for pepperoni pizza. We can't have pepperoni again, so we can either have sausage or mushroom. And then for mushroom first, we can have sausage or pepperoni. I'm going to write down our outcomes. Sausage, pep, sausage, mushroom, pep, sausage, pep, mushroom, mushroom, sausage, and mushroom, pep. So now we're going to cross out our redundant ones that are duplicates in a sense. What I mean by that is that sausage pepperoni is the same exact pizza as pepperoni sausage. So I'm going to cross out pepperoni sausage down here because it's the same pizza. And same goes for sausage mushroom is equivalent to mushroom sausage. You see how they just switched places. So I'm going to cross out mushroom sausage down here. And then we have pepperoni mushroom. It's the same thing as mushroom pepperoni. The reason why I'm crossing these out is so we don't have duplicate pizzas. We don't want to overcount the pizzas. So instead of these 6 outcomes that we thought, it's not 6, it's actually these 3. And it might help with this visual I'll draw up here. So we have, make that black. Here we go. We'll draw the 3 pizzas. These circles, or kind of circles, are pizzas. Now I'll do our sausage, which is underlined in red here. We have 2 pizzas with sausage on it. So I'm going to make 2 pizzas have little sausage dots. Okay. Now green is pepperoni. So we have 2 pieces of pepperoni. We have a pepperoni sausage and a pepperoni mushroom. Okay. Now last but not least, we have 2 pieces of mushroom. So we have a mushroom sausage and mushroom pepperoni and a mushroom sausage. See, these pizzas are representing all these different outcomes down here. That order, and today's lesson, we're gonna be getting into the whole concept of why that sausage mushroom is the same exact thing as mushroom sausage. They are the same. Versus if it was a permutation, when order does matter, if it was a permutation, it would be different. But we'll be, again, and then the next lesson we'll be learning how to differentiate between, today we'll be learning how to differentiate between a combination and permutation. Okay. So combinations. Combination is an arrangement of R objects without regard to order. So order does not matter without repetition, and it's selected. So it's that same thing where N is our total, same thing how we did for permutations, and that R is the objects being selected at the time. So number being, that's a B, selected. And it's going to be found on the calculator, and this function here is going to be found right underneath the NP, the permutation calculation on your calculator. And this is just the formula here. We won't really be getting too much into that, but we'll be mainly focusing on this and remember how we had those slots that we filled in for our permutations, like to conceptually understand it, we'll be doing that as well. So right here, we have our 4 movies. So Kate has 4 movies: The Avengers, Jurassic World, Toy Story 2, and The Lion King, and she's going to pick 2 movies to take with her friend to her friend's house. So we're going to make a tree diagram to help. So let's just say we have the first pick and then second pick. So we could either pick Avengers, Jurassic World, Toy Story, or Lion King. So I picked Avengers first. It's going to be very similar to that pizza tree we just drew. So you either pick Jurassic World, Toy Story, Lion King. And then as we go down, we're going to avoid writing the doubles. So because we already have Avengers and Jurassic World here, I'm not going to write down Avengers here again. I don't want to do that. Instead, I'm going to write our next option, which would be Avengers or Jurassic World, Toy Story, and then Lion King. And I'm going to keep doing that all the way down to avoid our duplicates. So then we could have T, and then what other ones? So we already have T, J, T, A. We do not have TL yet. And then we already have our other options. So L is not going to be drawn to anything. So we have either Avengers, Jurassic World, Avengers, Toy Story, Avengers, Lion King, Jurassic World, Toy Story, Jurassic World, Lion King, and then Toy Story, Lion King. Those are our only 6 options here. But so now that we drew out our tree diagram, I'm going to have you guys conceptually understand it, how we kind of did with those spaces. So we have our first movie, we have our second movie here. Again, this formula, I don't really want you guys to think as much about this formula, more so what you'd be typing into your calculator, which would be that it's the NCR. And so let's find out what our N is in this case. In this case, our N would be our total number of movies, which is 4 movies. And then our R, how many movies are we selecting to bring? We're bringing 2 movies, so R is 2. So in your calculator, you would type in 4C2. That's a 2. But to help you guys understand it, over here, see how I have these little slots drawn out here? Let's say the first movie, you haven't picked one yet, so you still have 4 movies to choose from. So we're going to put the 4 there. And if we already picked one, let's say we picked Avengers. So Avengers is out of the question now. We still have 3 left we can do: Jurassic World, Toy Story, or Lion King. Okay, and that is equivalent to 12. But you notice that when you type in 4C2 on your calculator, that's going to end up getting you to 6. And 12 is not equivalent to 6, so that means we have to do one thing. So now you'd actually end up dividing by the number of ways to arrange the 2 movies. Because remember how, let's say you pick Toy Story second. So if you picked Avengers first and Toy Story second, that's the same exact thing as if you would have picked Toy Story first and Avengers second. So that's why we're dividing. So we would take that 12 that we got in that permutation, but then we would divide by 2 factorial, because that's how many different ways you can arrange those 2 slots there. And that's the same thing as saying 12 divided by 6. Oh, sorry, 12 divided by 2. Wow. The answer gets you to 6. There you go. So now we got them equal. Okay. So again, remember, you take your permutation, and then you're dividing it by the number of ways to arrange however many slots you have filled in. Okay. Now let's move on to the next one. Okay, so a committee has 8 members. How many different ways can a president and a vice president be chosen? So you guys